Hello everyone, welcome. So this is Raga Handika again. So I would like to present a brief statistical analysis here using the four different languages: R, Julia, Mathematica, and MATLAB. And again, as usual, I provide a disclaimer here, so the material is as is without any warranty again. And again, opinions or idea here are as a capacity as my own, and do not express any view, opinions, ideas, and institution and personal views only. And let's go. I have already provided some background. Actually, I don't have any degree in the computer science or engineering here, but in the past I used MATLAB. I also use R and then switch to R, and then I recently learned Julia, and I also learned mathematics. So now that I also learned EQ, Stata, C++, some of you might have already used Python, but I cannot comment because I haven't used it. And I learned also Bahasa Indonesia, my native, English, some Germans, few Arabics, and also few Nihongo. So my work is teaching, research, consulting. But in here, I provide here as a personal opinion. So again, before you learn this one, you need to understand the basic about the R open source installation and package. You can go here. So first I can show you here. This one, okay. So this is the Sharon project here. It's you need to have already know how to install and package this. Okay. And also the second is the Julia. You can go to Julia language school. I show you here. So this is the download and then also packet. So you must be familiar with the installation and packet of Julia. Again, R and Julia are open source, so they are free. Okay, the next is Mathematica. It's actually proprietary, so no need for the package. You need to install, and there are free 15 days trial. But you know, we should know that this is a proprietary, which means a commercial software, so it's not free. But there is a free 15 days trial. Okay, and MATLAB is also proprietary, so no free. And there are, and you must be familiar with the installation and toolboxes. So toolboxes is the additional looks like packets, but according to MATLAB, we can buy the MATLAB and also additional toolboxes. So not necessarily all toolboxes. So you can go to here, MATLAB. Okay. So now let's go. What should I do in the three different languages? I want to do 3 plus 4, x 1 to 4, when, and then I want to draw a plot z is a function of the sinus p. So let's go one by one. Again, the best to learn is go to the code directly. So let's go to the R first. How we perform the R. So just do the basic. You can see here 3. Okay, you will see output here. Okay, 3 is just here 3 in here. You can see here. So and then 3, 4, and then sequential here. Yeah, okay. You can put the okay, so you get the output in here. So let me make bigger. Yeah. So if I copy paste, yeah, this is you can see the console if this is too small. And then I make the okay, so this is already clear. So if I want to make a plot, so I make a z here, plot sin pi here. Okay, so let's do here. Okay, so you can see this is a nice picture. So make it bigger here. Okay, this is y sin pi. So it's uh quite pretty easy. Okay, so this is the basic. Now the second is I want to show how to do the in the Julia language here. So yeah, so I need to type one by one. Okay, oh, where is it? The Julia. Oh. This is the Julia. Okay, so the Julia you need to. So can I make it bigger? Okay, yeah, yes, I can make it bigger. Yes, good. Okay, so let me make bigger, bigger, and bigger. Okay, now I need to type again to Julia here. I need to use okay, I just write 3 and then 3 and 3 plus 4. Yes, okay, I can draw like this. And then if I write to put correct like this, yes, I can. Yeah, okay, yeah. So this is a factor, and then I can write yeah, just type x. Now we get the collect, get the element vector. Now I can go see if I want to see what is using It's a function. Write the function first in the Julia, and then again using plot package is already added here. Okay, so then we try to draw like this. Okay, hopefully it works, and then let's see. Okay, so let's wait for a bit more. Yeah, okay, take a bit of while. Yeah. Yeah, finally, this is the picture in the Julia. Okay, so let's go to the next how we perform in the mathematical frame here. So here we go here. So here we go here. Okay. So let's do the basic here. Just press 3. Okay. And then again, this is input and output 3 and plus 4. Of course, you can change like okay, this for 4. Yeah. Okay. And then so let me see the table here. So we got the result. Okay. So if I write the table, it will be something like this. Okay, so this is just the syntax you need to form. Okay, if you want to make a plot here, you can see here. Okay, so let's see here. Plot. Okay, so now you want to check the label. Okay, you can do mathematical wolfram is like label here. Okay, it's nice. You can write label and then you can type done. Okay. Okay, but again, if you wish to do the quickly, go the output like this, and this is the output number 8. So type 8, and then this is you can also get this. Okay. So how you do it then in MATLAB? So in MATLAB, you can do here. Okay, so here we go. So this is the basic 3, 4, X. It's pretty similar. You can already see the result in here. Okay, so there are 200. But basically, you can see in the command window. So here you can write like 3, okay, 3 plus 4 here. So you can get the y in here. So it's this one. Okay, this is the you get the chart here. Okay, so the editor here, so you can write z sinus pin. You will get this nice picture. Okay, so let me make it bigger. This is. Of course, you have to. You can zoom or oh no, this is beautiful. Okay, so this is in the MATLAB. So now let's go. We have I want to read the file. So this is the example of the data file here. So you can have a look in the CFA. Again, I strongly recommend in the CFA, CSV here. Okay. So this is the structure. So you know this is the date, and then SPY 500 BTC USD, and then this is the dummy data 1 0. For the extreme high value. So basically, if you want to regress the return of this based on this is for example S1 and this is X1, X2, how to this is the regression. Okay. Actually, we can easy, but just recall the format might be slightly different. Now let's see. Okay. So now we want to read. So basically, in the R is the format is data read CSV and then the address. In the Julia, you need to do the CSV, and then I recommend to use data frame because we need to evaluate and analyze the data in Julia. And then the data is data frame, and then CSV file, then the name. In the Mathematica, it's import, and it's very convenient because once you type like this, you will show the data you want to show the path directly. So you can browse quickly. Similar with the MATLAB, but in the CSV read, there is a note here. Once you click this one, you must be active, and then you need to eliminate the header and only numerics. Okay, so that's the way they think. So let's go one by one. So in the R, you need to go quickly here. Okay, so let's clear it. Then yeah, if you can read. So if I can see the header, so you can see here. Okay, you will see this is the head. So the output will be something like this. They will be show the date and then USD and so on. Okay. Okay, now let's go how to work on Julia. Where is Julia? Oh, okay, I need to switch up. Okay. So in the Julia here, you need to using CFA and okay. So you need to use the using CSV. Oh, I haven't searched it. Yeah. Yeah. Okay, you need to using CSV with okay. Yeah, okay. And then you need to use data frame here. And then you can write like this. Okay. This is in my file, so this is a bit long. Okay, so this is long. So it takes a while again as the first, and then to read, and then Julia will read, and it will be nice. So just wait a little bit. So the first, some of the people, Julia work quite fast, but the first takes a bit. You can see it's really nice. So if you want to see the header, you can see the header data. So okay, so the next is how we read in the Wolfram mathematics. Oh, where's the mathematics? Okay, so in the mathematics here. Okay, so again, this looks like complicated, but actually it doesn't. So once you write the import, you can just this is the fly closer. So this is very nice. Okay, so I can go to the my file. Where is the mathematics and test here? Okay, right. This one. Okay, the file. Okay, yeah. So get quick. So if you want to see the data, you can see the table. It's quite nice. And then now the MATLAB here. Oh, let's go to the MATLAB screen. Okay. Okay, you can see the CSV read again. So make sure the active folder in left is this one. So because once you type this, okay, you will find the data this. Okay. So once you write CSV read like this is a recommended file, click one. But make sure you are on the active folder. And then you can write the data. So you will get the same output like this in this platform. Okay, I don't know how can I make bigger here. Okay. Okay, so that's in the MATLAB. Now let's go to the next. So we want to perform the statistical descriptive here. Okay. Oops. Yeah, I think I read it properly. Anyway, it's okay. So the next is the statistical. So in the descriptive example here, we need a package called T series, and then T series, and then for the Julia using statistic using uncertain data and using hypothesis test, and the data must be in column factor, has been numeric except either. So Julia, we can do it directly. And then for the mathematics, it's a bit tricky. Data structure must be numeric only. So this is similar to the MATLAB logic. So even in Julia has already header, but if you see the output in the Julia screen, you can see for the calculation, once you collect the factor, it's just been so let's go anyway to see that hopefully to the let's sorry. Yeah, okay, so let's back to R. So the data we would like choice is the data number 2 in column 2. So which is the S&P 500. Okay, so we want to analyze. So we will get easily the mean. So this is the output. Yeah. Okay, so we will get that output quickly. Okay, we want to also do the simple normality test. We use the Jarque-Bera test, and you can see the input of the series. Okay, so the output will be something like this. So it's quite nice. Of course, you can Google Jarque-Bera test in R, and then you will see the packet. So this is the R square, and then B value, and then decision. Okay. Okay, and then we can also perform the unit root test, which is in this case is ADF. So just very simple. Okay, so we get the output, so the output will be here. If you see the console, so I make it bigger. This is the output. Okay. Okay, so the next is how to use in Julia. So in Julia, it's Julia, because in the okay, we can get the mean data. So it's part case, you get the number, and then let's go to the standard deviation in the STD, means minimum maximum, so the standard, so you can see quite fast. And then in this case, need uncertain packets in the Jarque-Bera test here. Okay, and then let's go. Jarque-Bera test will be, you will see. You can see fail to reject it's 0. So we fail to reject the null hypothesis, which is the result might be slightly different to the algorithm, but the results are consistent. So in the Julia, we need to use the for the unit root test, we use hypothesis test, and then sorry, yes, sorry, with a typo. Okay, and then in the Julia, we use the ADF test data here, and then non-one. Okay, just yeah, so we get again, so rejects null hypothesis, and then we get the ADFT statistic here. Again, it's clear this is critical value in Julia. So now in the Mathematica, it's not exactly the ADF, but oops, where is the Wolfram here? Oops, I can show again. Yeah. Let me back to the Wolfram again. Yeah, okay, so let me back to the wall. This is okay. This is my Mathematica here. Okay, so let's go to here. Okay. Now in the statistical data, okay, I need to extract the header, so I should get the data like this here. Okay. So this is the here. Okay, so you can calculate manually. Okay, the first column, the standard deviation is the function of minimum and maximum. So in the normality test, we have like Jarque-Bera ILM test. So that might not actually be the same, but this is also nice. And in the truth test, augmented decoupleur and report the p-value. You can use decoupleur F or decoupleur T, but the result can quite close to the same. Okay, how you perform in MATLAB? So in MATLAB, it's also not difficult either once you have the statistical derivative. But again, you need toolboxes. Okay. Yeah, okay, you get quickly, and then GB test. Actually, if we want to do C here, the function is the statistic toolbox for the hypothesis test for the GB test, and also economic textbook for the time series for the ADF observation. Here for the ADF test or ADF. Yeah, augmented decoupleur test. Yeah. So this is the account toolbox. Yeah. But for the Jarque-Bera test, yeah, statistic. Yeah. So again, it's once you get the corresponding toolbox, it's not difficult. So you will get the format of this one. GB test. What is the detail again? You go to the how to get the value hypothesis P. You can go to the MATLAB documentation for the understanding. Okay. This is the documentation, for example, GB test. Okay. So you click, you will see. Okay, you will get this one, the syntax here, this is the explanation and example. So this is from of the MATLAB. Okay. So let me little back to the Wolfram again, Mathematica here. You can also have the strong documentation here in the Wolfram. So, for example, you want to search here. So, go to the help, okay, documentations, go to the, well, so it's very complete. So you need to test. Go to here. Okay. You can go to the unit root test here. Okay, this one, okay. Yeah, okay. So you can go to unit root. You can go to here. This is the example of the Wolfram documentation test, and so on. It's quite detailed. So that's very nice platform. Yeah. Okay, so the last part is correlation and statistical. Correlation and regression here. Just I want to explain you a little bit. There are difference about the R. It's clear correlation. We need the T series function. So sorry, this is the correlation in the should be blank. So this is should be blank. So let me delete. Yeah, okay. So let me delete. Yeah, I'm sorry for this one. So let me blank. Where's it? Anyway, so okay. So okay, so it will be correlation. I will show you later on. So the LM is Y, X1, and Xm. So it's simple. And then the data set. And Julia using statistic and then using GLM for the profit later on. So LM formula and then LM formula and then Y column factor, X1 column factor, and then X column factor. And then the data is a metric containing Y, X, and so they are, it's pretty similar. I will show this. Okay, in the Mathematica, but it's correlation metric form, and then a little bit we need to understand the data structure here. So it must be Y must be in here. That's what I say. Okay, so we need to rearrange that it's only a number and then x1, x2, x2, which is quite understand. I mean, if we know the linear algebra of basic statistics, so A is the factor column here, B is the factor column here. So yeah, the basic is like this is x1. So if A is a vector columns, B is vector column of B, so we need to data set and then transpose and then join A and B. This is the function. And then if we use multiple regressions, of course, this is x1, x2, xn, and so on. But basically, it must be x, and then we arrange like this one. So similar, if you solve the if you solve, and then the equation will be something like this one. Okay, data. You can use a structure matrix data set x and y, and then if you want to model linear but x squared, you can also make x squared, and then but only one variable. If we include constant basis false, without intercept and true with intercept. So if you want to do like x1, x0, okay, so put this one and don't forget to circle like this. Yeah. x1, x2, and then x1 power 2, it's fine, but there are only two independent variables. Okay. Okay, so in mathematics, you need to statistics material top toolbox and also economics toolbox for the correlation and then with LM, and then xy independent variable matrix and y is the dependent variable factor. Sorry. Okay, so let's back into the R again to the first example. So it's pretty quick. So you can write for the simple. Let's go. Okay, this is the data set. Okay, you can put. Okay, you can get. It's nice. So if you write the summary, the output is. If you write the summary, the output will be this one. So you can see there are coefficients. So let me, yeah. Formula, coefficient, significance, the error, p-value, r-square, and our statistics. So it's pretty nice. Okay. Yeah. Okay. So you can also do for the multiple regression as well. So you will get the output like this. Yeah. Now where's the output? So you can run the multiple. Okay. You get the output of the multiple regressions. Okay. So you have more than one variable. Yeah, so let me make it bigger. Okay, so this is the function. Okay, nice estimate standard error interval. And the last, let's try on the login here. Okay, M3 and then try to run the login here. Okay, so it must be, yeah, okay, you get this. So it's through the GLM to run actually. Yeah, you get this output. So estimate standard error and then click the login. Of course, you can also try probit. Yeah, this one so you can estimate standard deviation. Okay, so that's it. Now let's go how to run into the Julia. Okay, so the Julia is again we use the correlation matrix. So statistics packet. So assuming we have already done, so we can do correlation. So you can see this is the Julia. You can get the correlation matrix, and then if you want to use a GLM, don't forget to use the GLM here. Okay, Julia GLM packets, and then for the simple regression, you need to write the M1 here first. So this is the formula here. Okay, you will get the output there. Okay, just wait for a moment. Okay. The Julia language here. Okay. Okay. So this coefficient you can see quickly. Okay, coefficients are it's nice. And then if you want to extract the coefficients, you get the factor. You want to extract R square, you get here. Well, very small. Okay, the next is if you want to do the multiple regression, you can also do here. Okay, okay. Yeah, the same you want to extract the coefficients and R2, you can do it. Now you have two factors. You can see this double. Okay, the last is the logit you can use here. So this is GLM under this is the function. So you can see your data and then binomial. And don't forget add formula. This is Y, this is X, and then the data contained in the matrix. So yeah, you get it. Basically it's understandable. Okay, so the coefficient is 3. Yeah. So now how we run into the Mathematica. Okay, so let's back to the Wolfram again. So this is a very nice platform. Here for the correlation or regression. Again, once we set the data, we can just write correlation unit data in the metric form, and we will get the output is something like this. So again, don't forget to transpose. So in this case, every model we need to X and then Y. So we transpose the data like this. Okay, if you want to have a look, this might be again back to here again to the slide I show you. The most important thing is in Wolfram is we need to understand, we need to arrange the order correctly like this. Just put in the minus X and then Y. That's all. So once we got the X and Y, it will be much very easy. So we just go here. Okay, we get the M1 data. Okay, and then we get linear. Okay, it's nice. You can go parameter table here. You can go adjust the square. If you say, okay, what kind of the model one available, go to the properties. So so you can also see to here. So M2 it's similar. The most important is you transpose the data first, and then you get this one. Okay, so and then parameter table, you get this one, and then just the R square and the properties. You get. And if you want to use logit, okay, so just a little bit work to in the transpose and then M3. So this is the logit parameter table. AEC now is the properties. So that's all. And last, how we do in the MATLAB, so correlation and regression again. Correlation, just the data, you will get the yes, the metric correlation average, and then regression again. We need to rearrange data again in the X independent and Y matrices. So the matrices will be X again, similar to the Wolfram. So X matrix and Y matrix. So this is simple regressions. Yeah, you will get fit LM. This is the output here. So you can also know what you know the M1. Click in the workspace here. You will see the content of the what is the one in the multiple regression. You just do the 2 You get, and then log it, and then this is a bit tricky. Fit GLMXD linear distribution binomial and log it. Fit GLM. You will get it. So this is, let me make it bigger. Sorry. Okay, this is the output of linear regression, and this is the output of the multiple, and this is also for the login. GL, generalized. Okay, I think that's for today. Thank you very much for your attention. I hope you enjoyed the 4 different languages. Thank you very much.